So inverse trig functions are the opposite of trig functions. We've been working with trig functions in like the forward direction, and today we're going to work in the backward direction, is pretty much what I'm saying. For sure. One moment. I saw that chat. Let me just do that really fast. I'm going to, let me see how I can do this. Try that. I think that should work. Okay, so today we're going to work with trig functions. Trig functions, I'm just going to remind you, we have done things like find the sine of pi over 4, right? Find the sine of pi over 4. When we find that sine, what we are essentially saying is we're finding the trig relationship of this angle. And the angle can be in degrees or radians. And they've been asking us to find the fraction that shows that relationship, right? Today, as we're thinking about this, we're going to find, they're going to give us the relationship, and we're actually going to find the angle, right? They're going to give us the relationship, we're going to find the angle. So let's refresh, let's go forwards one time so that we remember, right? Is there anyone who feels like, whew, I can do this, I still remember how to do this? Anybody want to come off mute and talk us through this one? I'll give 10 merits to the person who wants to do this. 10 merits, starting off huge today, because this is, you know. Great, Galilee, come off mute, tell us about this one. Or at least get us started. Okay. Wait, all right, Galilee, tell us where 45 degrees came from at least.
So you start off with pi, which you'll use as the 180, and then you would divide it by 4, and you would end up with 45 degrees.
Cool, thank you. So we're really doing like the sine of 45 degrees. Is there a brave human who could tell me where 45 degrees is on the graph? Like, how can I draw this 45 degrees? Is it in the first quadrant, second quadrant, third, fourth? First quadrant, yeah, first quadrant over here. Nice. First quadrant, we're just getting our brains warmed up. All right, so I've got 45 degrees. I'm gonna go ahead and drop that line straight down. What does that mean that this other angle is? What does that mean that 45 is? Yeah, 45. So this is a 45, 45, 90 degree triangle. What does that mean about the side lengths? What do I know about the relationship of the side lengths? Anybody remember? There was like, there's 1, 2 square root of 3, and then there's 1, 1 square root 2. And Galilee's got us in the chat. It says 1, 1 square root 2 for sure. So we have 1, 1 square root 2. Is anything negative in this triangle? In that first quadrant, is anything negative? No, nothing's negative, right? Everything's positive. So we have 1, 1 square root of 2. All right, so we've got this. We've got this so far. We have our sine. We're looking for sine. Can anybody remember what's the fraction? Like, is it like XYR over XYR? Sine is, yes, good job. Sine, remember Y over R? I don't really know why that, I don't know. I never really know, but it's Y over R. Sine Y over R. So in this case, we would have Y is 1 over R, which is square root 2. Are we done? This looks pretty good. We have a ratio. It is close to done, but what do I still need to do? Rationalize, absolutely, Devin. Right, I'm gonna rationalize, so I'm gonna put square root of 2, multiply by square root of 2 on top and bottom. I get square root of 2 over 2. as my answer. Whew. Okay, let me just get like a general feeling of how, oops, definitely forgot that map hole. Let me feel like, how are we feeling on this? Like, how are we feeling on just like remembering, shaking off the cobwebs of this problem we just did? Cool. Take about 10 more seconds. Just let me know, how are you feeling? Do we remember this? Cool. 5, 4, 3, 2, and 1. Thanks for voting. Let me just show you. No one is alone. No matter what you chose, no one is alone. So if you're a 2, there's somebody else like you that's a 2. If you're a 3, there's someone else that's like a 3. If you're a 4, there's a lot of people out there who are 4s. If you're a 5, there's a lot of people out there who are 5s. Right. So I appreciate you. This feels right for like where we're at based on it just being a long time since we've done this, right? So cool. Let's go ahead and think about the new directions that we're going to have. So this has been the forward direction. They've been giving us the angle, and we're going to find the ratio. Today, we are going to build off of that. We're going to use those same skills, but we're going to work the other direction. This time, they're going to give us a ratio, and we're going to find the angle. The official directions are here. Find the value of t, so in this case, the angle, given that t is in between 0 and 2 pi. So the measure of the angle is in between 0 and 2 pi. If this says 2 pi, do you think we're going to have our answer in radians or degrees? If it goes up to 2 pi, does that give you a clue that it's radians or degrees? Galilee, make an argument for degrees. Why does that tell you that we're going to do it in degrees?
When we had the pi over 4, well, we already know that pi counts as 180 degrees. So if we have 2 pi, then it would give us like the full circle. So we're going to be talking degrees.
I like that. What I like a lot about that, Galilee, is that you recognize that we had degrees, or we had radians before, and we actually turned it into degrees in order to like do our problem. We're still going to do that, but this 2 pi actually tells us that our answer needs to be in radians, right? It tells us our answer is going to be in radians, even if we use degrees along the way. So I agree. I want to use degrees. Degrees are easier to me, right? But our answer is actually going to be in radians. Thank you for making that argument, Galilee. It says use the coordinate plane to draw the reference triangles. This is something we've done in the past. We have drawn our reference triangles. Notice it does say the word triangle. We're actually going to draw 2 triangles today. All right, let's jump in. It'll look better. I do want to acknowledge there are some that are highlighted here. Those are the ones that I'm going to hit specifically today, or at least attempt to. I have done all of them on the video if you want to check them out. Particularly G and H are like a little more challenging, but there's none like G and H on the homework, so I didn't want to like freak you out. But if you do want to see it, you can watch the video. So D, G, and H are on the video, as well as all of these ones here. Let's jump in with this one. All right, so sine t equals the square root of 3 over 2. So this is the ratio, this is the fraction, and we want to find the angle. That's our goal, to figure out what angle equals this. So what ratio, right? Is it what's on top and what's on bottom? Is it x, y, or r on top, and x, y, or r on bottom for sine? For sine. Is it what over what? We just did a sine problem. Yeah, there you go. Thanks, Kayla and Jimmy. It is y over r. Y over r. So in this case, square root of 3 is y, and 2 is my r. Right? So I know that the square root of 3 is y, and 2 is my radius. So in what quadrant is y positive? In what quadrant is y positive? Where do we have our positive y? In the first quadrant, there's a positive y for sure. So we could have this line here. We'd have square root of 3 as my y and 2 as my radius. Devin, can you talk to us about, Devin Z, can you talk to us about why you also said number 2? I agree. Also number 2. The y is still positive. Absolutely. Over here, the y is still positive, even though the x is negative, for sure. Thank you, Devin, for those messages. The y is still positive, even though the x is negative. But in this problem, we don't know anything about x. X doesn't have to be positive or negative. It just tells us that we have a positive y and a positive r. Remember, our radius always has to be positive. Right? Cool. Okay, so there are actually, it's okay, Devin. There are actually 2 triangles, right, where this could be true. That means that there are actually 2 angles where this could be true. So the first angle is this one here, right? From here to here. We need to know what the purple angle is. And then the second angle is all the way over here, right? So we're going to figure out what the green angle is. The green angle. So we're going to figure out what the purple angle is and what the green angle is. So for our purple angle, I know that this is 2 and square root of 3. Using my special right triangles, what number is this? Yes, absolutely, Christine. It's a 30, 60, 90 triangle. What number is x in a 30, 60, 90? 1, yes, 1. So I have a 1 here, right? It's 30, 60, 90. So I have 1, 2 square root of 3. Remember that the shortest side goes across from the shortest angle. So is this going to be 30 or 60 up here across from the 1? 30 or 60? Shortest side, shortest angle. Yes, absolutely. 30. This is my 90 for sure. And so then what does that mean the purple angle is? What is the size of the purple angle? 60 for sure. Thanks, Fatima. 60 degrees. So this one here is 60 degrees. That is one of my answers. One of my answers. All right, let's deal with the green triangle. The green triangle over here. So in order to solve this, I need to know this reference angle here so that I can take it away from the whole thing over here. This one over here, Christine told me earlier, would be 1. It's going to technically be -1. That means up here we have 30 degrees. Here we have 60 degrees and our 90. 30, 60, 90. Okay, here's where we have to do some critical thinking. We know 60 is this section of this triangle right here. But what does that mean that this big part is here? What is this big angle from the beginning, right? From the initial ray all the way to the terminal ray, the green one? What is that? Gally, I think yep, there you go, 120. Gally, can you tell us about why you got 120?
You know that a flat line is 180, and since you're looking at the triangle on the left, you know that your angle that you have covered is 60 degrees, so you would subtract 180 minus 60, and then you would get 120.
Absolutely. Thank you, Gally. The whole thing is 180. We already know this part is 60, so we're taking away that part, and we have 120 is left over for that green section. So we have a possible angle of 60, a possible angle of 120. The reason why there are 2 is because the sine of two things is this ratio here. There are two triangles that can be drawn, right? So the sine of 60, if I put that in my calculator, I get this as my answer. The sine of 120 degrees, if I put that in my calculator, I get this, right? You can actually see that on your calculator. See that on your calculator here. I think I actually already did it, maybe. So we have the square root of 3/2 is this number here. I transitioned this to radians already, but I'll show you in degrees here. If I put 60 here, put my calculator in degrees, I have the sine of 60 gives me this ratio. That ratio is the same decimal, right? The same is true if I have 120, right? Notice like 12, not the same ratio, but 120, it is the same ratio. That's how I know that these are equal to each other. The sine of this angle is equal to this fraction here. So one thing we do need to do before we move on, because the question tells us to find the value of t, given that t is in between 0 and 2 pi, they're asking us to use radians. So we can't leave our answer in degrees. Does anyone remember from the big four, what is 60 degrees? How do I transfer that into radians? How many pieces? Absolutely, Devin. Pi over 3. I might remember like you have 180, right? 180 divided by 60, that'd be 3 pieces, so pi over 3. All right, so if 60 is pi over 3 and 60 times 2 is 120, what would the radian version of what's 2 times pi over 3? Yeah, just 2 pi over 3. Good job. 2 pi over 3. If that feels complicated, if you're like, wait a second, what? How did you all do that in your head? They memorized those things in their head. If you want to do it by hand, you can always do 60 times pi over 180, or you could do 120 times pi over 180, and then you'd get like the 120 pi over 180, and then simplify this, and you would divide by 6 on both sides, or on top and bottom, you get 2 pi over 3, like that. So you can do more of the like longhand algebraic version. This is just like our memorized version here. So those are my 2 answers for this type of problem. Let's break down our pieces here. Our first thing here was to label, right? The first thing we did was label, right? Just as we've been doing. The second thing that we did was draw the triangles, right? Draw the triangles, and we drew both of them, right? 1 and 2. Right. The third thing that we did was figure out the angles, right? The third thing we did was figure out the angles. That gave us our answers here. And then the fourth thing that we did was convert to radians. I would say the second step and the third step, these are our most complicated steps, right? Drawing the triangles, figuring out where to draw them, and figuring out what the angles are themselves. I expect that many of us are feeling confused. Tell me how confused you are feeling. Tell me how you're feeling. I expect that many of us are a little bit confused. That is totally okay. Thank you for your honesty. Awesome. Thanks for voting. All right. Cool. We've got lots of 3s and 4s, mostly 3s and 4s, and then a few 1s, 2s, and 5s. So looking good. Thanks, y'all. All right, let's try another one. As you feel confident, if you feel like, oh, I think I would like to be called on, feel free to raise your hand. If it is quiet enough for you to come off mute, totally understand if that's not possible. All right, so first things first, we need a label. First step is to label. I'll leave this one like sort of up here like this. If I have cosines, what is my labeling? what is my labeling? Wow, this flag is brutal. All right, if I have cosine, my labeling is, yes, Kiara, x over 4. Or x over r, not 4. I don't know where that comes from. X over 4. X over r. Okay. Can my radius be negative? I know my fraction is negative. Can my radius be negative? No. Remember radius, like it's just the distance, right? The distance from the center. My radius cannot be negative. So 2 is my radius. Can x be negative? Yeah, x can be negative, right? Our x is negative over here. So in this case, x is -1, right? So I know that x is -1. I know my radius is 2. There are 2 triangles. What quadrants allow my x to be negative? What quadrants allow my x to be negative? Absolutely. Number 2 and good job, Kiara. Good job, Jimmy. 2 and 3. 2 and 3. So here I have x is negative. I have one possibility for here and one possibility for here. Okay. What did I say that my radius was according to the label? What is my radius length? What is the radius length? What number? How am I going to label my triangle here? 2. And what about this one over here? Also 2. Thank you. Thanks, Sally. Thanks, Araceli. Okay, what is my x here? What is x? -1. -1. So this is -1 as well. So if this is 1, 2, what's the y value here? It's not a 45, 45, 90. It's not 1, 1 square root of 2. It's 1, 2. What is this one here? Yeah, square root of 3. Square root of 3. Thanks, Fatima. Thanks, Valerie. So I have negative square root 3 here. So we have 1, 2, square root of 3. Right, if this was square root of 2, then we'd have 1, 1 square root of 2. All right, so we have this. This is our 30, 60, 90 triangle. I know my 90 is here. I know that my shortest side is across from my shortest angle. So I know this is going to be 30 up here and 30 down here. What does that mean that this interior angle is for both of these? What does that mean? 60. I'm going to go ahead and erase our -1 here. 60 degrees is here. So our reference angle is 60 degrees. Thanks, Gali and Araceli. Our reference angle is 60 degrees. Our first angle is this purple angle from the initial ray to the terminal ray. How big, how many degrees is the purple angle here? Yes, 120 degrees. The entire thing is 180. The flat line is 180. We already know that 60 is here, so we're taking away the 60. This is 120. Right, so I know that 120 is one of my answers. That's my purple. I'm gonna erase this part here. Okay, this one, it might seem funky. I gotta get to this line here. If I go all the way around here, there you go, this whole distance from the beginning, from the initial ray, all the way to the green terminal ray here. How many degrees is that? I go all the way and then here. Galilee, I see your 240. Why are you thinking 240? $180 plus 60. For sure. We have our whole 180, the first part here. is 180, and then we know this initial part, or the like next part here from the triangle is 60, right? So we have 180 plus the 60 would be 240 degrees. Absolutely. So we have our two triangles, our two angles that can make this ratio here. So we have 120 and 240. Can anyone help me put them into radians? Put them into radians. I already know the 120 is 2 pi over 3 from the last problem. So I know this is 2 pi over 3 as my first answer. So then if that is 2 pi over 3, if this is double, what's double 2 pi over 3? Yeah, that's 4 pi over 3. My green one would be 4 pi over 3. So my two answers are 2 pi over 3 and 4 pi over 3. Can I repeat how I got 240? Yes. So 240 is twice as much as 120. So 120 times 2 is 240. And since this is 2 pi over 3, twice, like 2 pi over 3 times 2, 2 times 2 would be 4 pi over 3. If that's feeling clunky, yeah, for sure. If that's feeling clunky, you can always do 240 times pi over 180. And then you can simplify that and you'll still get 4 pi over 3. For sure. Thanks for asking that question. All right, let's do C together. All right. For tangent, first things first is to label. First things first is to label. So this is 1 over 1, any number just over itself. What is tangent as a labeled fraction? What is on top? What is on bottom? Y over X. Yeah, Kira, great job. Y over X. Okay, remember there are two triangles where this could be. Two triangles where this could be. So with tangent, we have a positive Y and a positive X, right? Positive Y, positive X. What quadrant can positive Y, positive X go into? What quadrant? Yeah, for sure. Number one. Number one, we're going to have this one here. This is kind of tricky. Can anyone figure out where could the other one be? There needs to be two triangles. Yeah, Devin, number 3. Devin, why number 3? Why quadrant 3? A double negative, yes, for sure. In order to get 1, you could also do -1 over -1, right? -1 over -1. A double negative would also give you that ability. So you could have -y and -x. That would, when you divide them, it would still get you that +1. So it's kind of a trick. Some teachers ask their students to just memorize that tangent. When you have tangent, it's going to be in quadrant 1 and quadrant 3. Right? Quadrant 1, quadrant 3. You're going to have the double positive version or the double negative version, for sure. All right, so we have our two triangles. I'm going to label them. I have either X is 1 and 1, or X and Y are both 1 and 1. This is our -1, -1. If I have 1 and 1, what is my radius? 1 and 1, what's the radius? What kind of triangle is this? It is 45, 45, 90. Yes, thank you. So we have square root of 2 as my radius. So I have 45 degrees here, 45 degrees here. All right. This is an easy one. What is the first angle? How many degrees is the first angle? The purple angle there. 45 for sure. 45 degrees is our first answer. All right, let's talk about the green one. It goes all the way from the beginning, all the way to the end. What number represents the green angle? Remember, I have the full 180 and then 45 more degrees. The full 180 and then 45 more. Yes, Walter. Golly, good job. We're going to have 225 degrees. We went the full 180 and then 45 more. So don't subtract 45, that would be up here. 45 more here. All right, 45. 45 is one of the ones we memorized. 45 is one of the ones we memorized. What is its radians version? Pi over 4, yes. Pi over 4. And then I'm thinking, okay, there's 4 of them. So 45, 45, 45, 45, and then another 45. So this is 1, 2, 3, 4, and a 5th one. So that's how I know that this is 5 pi over 4. So there's 1, 2, 3, 4 of them on the top, and then a 5th one on the bottom here. Again, if you're feeling like that's what, miss, I don't know what you're doing there, you can do this version here. And then just simplify 225 over 180. 225 over 180. Okay, friends. Let me see. After seeing those 3 examples, how are you feeling now? We were 3s and 4s after the last example. Cool. Awesome. Okay. Thank you for your honesty. You are not alone. Everybody has another person that is picked the same number as them. All right, friends. Okay. It is 10:30, so I want to just detail where you can find the rest of the information. I don't actually think that you need E and F in order to understand what to do. I think you got it. The only reason I wanted to do E and F was because secant and cotangent, those are just the flipped version, right? Remember, secant is the flipped version of cosine. So you're just, instead of x over r, you're just going to put r over x. That's the only difference, right? Cotangent is the opposite. So just put it over 1. You would have x over y, like that. I absolutely walk these through in slow detail all the way through. So if you want to watch the rest of them, you can check out the video, right? I know our brains are in a complicated space. So I just gave us 8 problems. 8 problems is the total amount. If you're spending more than 40 minutes, I want you to stop, turn it in, send me a text message, miss, it took me more than 40 minutes, right? I want 40 minutes to be your max, right? Please, I know we have some really, really high achievers in this class, but don't spend more than 40 minutes on this. So 40 minutes total. You're choosing 8. So if one gets like really funky and you're like, I don't know what to do, skip it and move on. You have all the answers are written here. If you don't find your answer, let me know. I did them all by hand and I actually wrote them all down on paper. So I have an answer key and I think they're correct. So let me know if you think that they are incorrect. Okay. If you have any questions, we'll be here from 10:30 to noon today. If you want to pop back in, you're welcome to. Otherwise, have a great day in Spanish and I can't wait to see you on Thursday. Bye, friends. Bye. Adios. Bye. Thank you. Bye. Bye, Marley. Bye, Kayla. Bye, Devin. Bye, Axel. Have a good day. Bye, Gally.